Good afternoon to all. Welcome back to Basic Circuit Theory. This is lecture number 34. And today we are going to start a new topic on the last topic of coupled circuits, last topic of unit 4. It is tuned circuits. So let me put the heading tuned circuits. Okay. So what do you mean by tuned circuits? My question, are you tuned with me? Anyone? Are you tuned with me?
Yes, sir.
Okay. Yes. Okay, you are having 2 years, right? Here, tuned means you are listening me through ears, and you are having 2 years. How many ears are tuned with me? Two or one? Sometimes only 1 year, right? And to get better clarity, to get better accuracy, sometimes both ears, right? So here also you are having, single tuned circuit and a double tuned circuit. Single tuned, like classroomல இருக்கீங்களா அந்த மாதிரி. So single tuned circuit and double tuned circuit. Okay, first of all, what do you mean by tuned circuit? Okay, in general, you know what do you mean by tuning. But coming to circuits point of view, communication point of view, as we discussed earlier, you are changing the knob of your FM, right? Take the FM hardware setup. As I told earlier, you are changing the knob. So what you are doing, inside actually you are having already what I told. You are changing the knob, you are changing the capacitance, but inside actually you are having one tank circuit. What do you mean by tank? This is capacitor, parallel combination of capacitor and inductor. Okay, this is called very interesting. Okay, circuit in communication point of view, it finds lot of application. One application is your FM. Actually, in your FM, okay, if you are having any FM in your home, just try to broke. Okay, inside you can find this tank circuit. Okay, actually here this L is fixed, and one more thing, this L is very low, so you cannot change this. That's what you are changing this capacitor, and it is a variable one. And you are changing the knob, right? You are changing the capacitor, and here the frequency, that already we discussed. F equal to 1 divided by 2 pi square root of LC, where L is fixed. L is fixed by changing C. Okay, I'm putting arrow mark in C. By changing C, okay, it may be 93.5 for Surin FM, 98.3 for Merci. That so this tuned circuits finds application in FM. If you are having one tuned circuit, in your hardware setup, that is called single tuned circuit number one. But sometimes ஒரு காது மட்டும் கேட்டா நல்லா இருக்காது இல்லையா? கேட்காது. ஸோ நான் ரெண்டு காதும் கேட்டா நல்லா இருக்கும் இல்லையா? அதனால to improve the stability, to improve the accuracy, okay, we moved to double tuned circuit. But in your syllabus, you are having only single tune. You don't have double tune. This is just for your knowledge. Okay. So I want to discuss only single tuned circuits. So let me put the heading single tuned circuits. Okay. So this is in coupled coils. So how to sketch the circuit diagram? So take two inductor. Okay. Take two inductor. Just to make, just to couple these two inductor. Take this one inductor is L1, this one inductor is L2, and make a wireless connection. It's nothing but coupling, right? So this coupling, this is my mutual inductance M. Here this dot rule, here it is plus. Okay, the dot rule. Here this dot, here this dot. Okay, and as I told you earlier, so input side always we will apply some voltage source. We will apply some voltage source. This is plus, this is minus. It may have some internal resistance, right? So it may have some internal resistance. Take this is source resistance and this is my source Vs, or take this is my input voltage, okay, Vi, and this is a tuned circuit. So definitely you want to connect one capacitor because then only it will act as a tank circuit, right? Parallel combination of L and C. So here you want to add this capacitor and measure the voltage across the capacitor. That will give you output voltage V2. Okay. So here the current direction is very important. So I1 in clockwise direction. Here I2, that is also in clockwise direction. So this is the way to draw, okay, the circuit diagram for single tuned circuit. Any doubt? Do you want to repeat this? Yes or no? Do you want to repeat this diagram? How to sketch the circuit diagram for single tuned circuit? Or is it understood?
Understood, sir.
Okay. But take any inductor like as the inductor also it may have some internal resistance, right? So take this is some L1. So this time take this is some R1. The internal resistance of inductor. So here I want to actually internally it presents, okay, R1. So here it is R2. Okay, the internal resistance of L1 and L2. Okay, it is contained in series with inductor. Every system has its own internal resistance, right? So I want to consider the internal resistance of R1, R2. Here the very first assumption, okay, very first assumption, please make this RS, right? The source resistance RS, which is very, very greater than the internal resistance of coil 1, and this internal resistance of coil 1 actually it is very, very greater than the internal resistance of, I mean the reactance of inductor. That's what here I have given. This L is very low, it is fixed and it is very low, right? And it is very, very low when compared to these source resistance as well as the internal resistance. Think about internal resistance விட கம்மியா இருக்கணும், then only you can achieve, okay, better tank circuit. That is the very first assumption, you please make a note. Okay, therefore from this what is our conclusion? Rs plus R1 plus JL1 omega. If all are connected in series, okay, then what is the equivalent resistance? Both will be I mean all are will be added, but here all will be added, but here Rs plus R1 plus JL1 omega, which one is having, if we will connect to two resistors in series, okay, or otherwise let me write like this, RL plus R high. If you will connect, okay, one low value resistor with one high value resistor in series, what is the equivalent resistance? Almost equal to, please respond. ஒரு லோ வேல்யூ ரெசிஸ்டரையும் ஒரு ஹை வேல்யூ ரெசிஸ்டரையும் சீரிஸ்ல கனெக்ட் பண்ணோம்னா ஈக்குவல் டிஸ்டன்ஸ் எப்படி இருக்கும்? ஆல்மோஸ்ட் ஈக்குவல் டு
R high, sir.
R high. Suppose if we will connect in parallel, RL parallel with R high, this is almost equal to R low, right? So here which one is high? RS is very, very high when compared to the remaining two. So I made the very first assumption. From that I derived the relation, okay, Rs plus R1 plus JL1 omega, which is almost equal to Rs. Okay. So now here I want to find the voltage gain. Okay. So let me find the voltage gain. It's very important to find voltage gain, denoted as gain is A and this is voltage. So A sub B. What is the formula to calculate voltage gain? Let me assume this is an amplifier. Okay, this is an amplifier, just to assume. I am giving some input some 5 volt and I am getting some output some 30 volt. Assume I am giving input is 5 volt, output is 30 volt. What is your gain? Anyone? I'm giving you 5 rupees. Okay, with the help of that 5 rupees, okay, you are doing some business, just assume, and you earned, 30 rupees. So what is your gain? How will you calculate gain? Anyone, please? How much your gain?
Output by
So this is 30 divided by 5, which is equal to 6, right? So it's nothing but output divided by input. Yeah, very good. Thank you. So here also, output voltage, it is V2 divided by input voltage, it is V1, right? Okay. What is my output voltage? Anyone? Output voltage, okay, the voltage across the resistor, right? The voltage across the resistor, this is my output voltage. Okay, so this is plus, this is minus, where current is entering. Okay, so V equal to I times R, V equal to IR from Ohm's law. So where I equal to I2, what is the reactance offered by capacitor? 1 divided by J P omega. Okay, so output voltage. Actually, my aim is I want to calculate voltage gain. The formula is V2 by V1. So the flow எப்படி இருக்கும்னா, you want to start from V2, okay, and please proceed, okay, till you get V1. That is the flow. Got it? Derivation step by step. ஒரு ஸ்டெப்ல இருந்து அடுத்த ஸ்டெப் ஏன் போறேன், எங்க ஸ்டார்ட் பண்ணணும், எங்க முடிக்கணும், இந்த கீ பாயிண்ட்லாம் நான் வச்சுக்கிட்டேன்னா it is very simple, then you can enjoy the derivation, right? So my formula, it is voltage gain, very simple, output divided by input. So obviously we will start from output. So my output voltage, V equal to I times R, where I equal to I2, R equal to 1 divided by JC omega. Okay, so here what's my next step அப்படின்னு பார்த்தோம்னா, இந்த JC omega இருக்கு இல்லையா, இதெல்லாம் constant. So you want to calculate I2, where I2 alone variable, where I2 is variable, whereas this one is constant. Okay, so you want to find I2. How will you find I2? In order to calculate I2, you want to apply KVL at loop 1 and loop 2. By using mesh analysis, actually we are going to calculate I2. Okay, so for that, let me first apply KVL at loop 1. Apply KVL at loop 1. Okay, let me copy this diagram. First I want to paste it here, then it becomes easy. Okay, apply KVL at loop 1. At loop 1, how many voltages? This is minus 2 plus, so minus V1. Here no polarity for resistor, but always you want to take current entering as positive. Here current is entering, that is I1. So here the voltage drop is I1 times Rs. It is plus I1 times Rs. Then here, it is L1. Okay, so the voltage is voltage V equal to I times R, where I equal to I1, R equal to J L1 omega. Okay, plus it is having some internal resistance, that is R1. So what is the voltage drop at R1? Obviously it will be given by I1 times R1. Okay, so what else remaining? What about this mutual inductance? Is it positive or negative? Mutual inductance, dot conversion rule, right? Okay, now let me know, is it positive or negative? Think well and let me know. Take loop 1, current I1, is it entering into the dot or leaving from the dot? Loop 1 la entering, leave loop 2 la leaving. So it is positive or negative? Negative. So be careful. நம்ம ரெண்டு டாட்டுமே இங்க இருக்கு, இங்க ஒரு டாட் இருக்கு, obviously இங்க ஒரு டாட் இருக்கு, இங்க ஒரு டாட் இருக்கு, நம்ம பார்த்தோன்னே பாசிட்டிவ்னு தோணும். But think about the direction of the current. Okay, we assumed both in always clockwise, so that's why it becomes minus. Okay, what is the voltage drop because of that mutual? V equal to I times R. This time I is because of The current which is flowing through loop 2, okay, will generate EMF at loop 1, that is your mutual. So I2 and J, this time this is M omega, right? So which equals 0. Got my point? So I started from source minus V1, then voltage drop across RS, then voltage drop across inductor, then voltage drop across the internal resistance of the inductor, then finally voltage drop because of mutual inductance, right? So now எப்படி எழுதணும் இதை நம்ம மெஷ் அனாலிசிஸ் you want to write I1 and I2 in terms of I1 and I2. So this is V1, okay, bring this minus V1 to the right hand side, becomes V1. So V1 equals coefficient of I1, it becomes RS plus JL1 omega, okay, plus R1 minus JM omega I2, okay. But what was our assumption from this? RS plus R1 plus JL1 omega. This is almost equal to, what is the voltage drop across L2? இருக்கீங்களாடா? லிசன் பண்றீங்களா? Put on signature, okay, that's what delay. So what is the voltage drop across L2? That is, J, okay, L2 omega times I2. V equal to I times R, where I is I2, and plus internal resistance R2, so R2 times I2, plus what is the voltage drop across this capacitor? I2, 1 divided by J C omega, where R is reactance offered by the capacitor, 1 by J C omega. What about mutual inductance? So minus J M omega, it is because of I1. Okay, so now what about this one? Minus J M omega I1, coefficient of I1, plus coefficient of I2, it becomes R2 plus J L2 omega, okay, plus 1 by J C omega. Okay, this is my equation number 2. Any doubt in developing equation number 1 and 2? Just apply KVL, mesh analysis. Okay. So now my aim is I want to calculate I2 by using, Grammar's rule. Can you remember what is the formula to calculate I2? This is del 2 divided by del, where blue color use பண்ணி ரொம்ப நாள் ஆச்சுல. Let me choose a blue color. Okay. So where del 2, what is del? Okay. So del, it is given by, equation number 1, it is RS minus J M omega. Equation number 2, it is minus J M omega. This is R2, okay, plus coming here, okay, take J as common. What will happen? This can be written, okay, R2, this is I2 times R2 plus take J as common, it becomes L2 omega. Okay, here is actually 1 by J, so it is minus J. I took J as common, so obviously it becomes minus 1 by C omega. Okay, so this can be written R2 plus J times L2 omega minus 1 by C omega. Okay, this is my del. What about del 2? So del 2, there is no change in column 1. So it is Rs minus J m omega. And you want to replace, okay, column 2 by V1 0, right? So it becomes V1 and it becomes 0. Okay, this I hope so you can remember the Cramer's rule, del 2 by del. So now this is my I2. So I2 becomes, anyone is listening? இல்லை தனியா பேசிட்டு இருக்கான்? Okay.
Listening, sir.
What is the numerator for I2? What will happen? This is Rs times 0. It becomes 0. Just a minute, wait. ஒன்றும் கொடுக்கல சார், எதுவுமே சூரியனுக்குமே கொடுக்கல, எதுக்கும் கொடுக்கல. வேணும் இன்னொரு செக் பண்ணி சொல்றேன். 2 டைம் கேட்டேன், கொடுக்கல. சொல்றேன். So what is the numerator? Rs 0.
Sir, எல்லாம் ரெக்கார்ட்.
என்னம்மா அது பரவாயில்லம்மா, இந்த லிங்க் வேணா அனுப்பாம இருக்கு. நீ இதுக்கு மட்டும் வந்துரு சரியா? இவ்வளவு நேரம் கொஸ்டின் கேட்டு ஆன்சர் பண்ணியால. அந்த ஸ்டூடெண்ட் யூனியனுக்குலாம் அப்ளை பண்ணீங்களா? அவங்க அதான் கேட்குறாங்க. அதுக்கு யாருமே நான் இது அப்ளை பண்ணவே இல்லையா? யாராவது இன்ட்ரெஸ்ட் இருந்தால் அப்ளை பண்ணுங்க. ஸ்டூடெண்ட் யூனியன் நான் ஒரு சர்க்குலர் அனுப்பிச்சோம்ல, விக்னேஷ் உனக்கு அனுப்ப சொன்னேன். அனுப்பிச்சே இல்லையான்னு தெரியல. சரியா?
அனுப்பிச்சேன் சார். அது சங்கமே அபராதத்துல ஓடிட்டு இருக்கு அப்படின்ற மாதிரி நிலைமையில இருக்கு சார். அது
ஏன்டா?
வாங்க சார், பிசிடி முடிச்சிடலாம். சூரியரை போட்டுலாம் பார்க்கணும், டைம் இல்லை.
நல்லா இருக்கான் படம்.
பார்க்க விட்டாதானே சார் கடைசி நாள் வரைக்கும் வேலை கொடுக்குறீங்க.
நாங்களாம் சும்மா உட்காந்துட்டு இருக்கோம். இப்ப நீ மட்டும் தான் கிளாஸ் கவனிக்கிற. சரியா? ஏன்டா உனக்கு மேல எனக்கு வெளியே காட்ட முடியல.
வாங்க சார், சீக்கிரம் முடிச்சிட்டு
ரெக்கார்ட் வேற ஆயிடுச்சு. Okay, so what is a numerator? It becomes, minus of minus j m omega times, which is v1, right? At v1. What about denominator? So this is, this into you want to multiply. So it becomes Rs times R2 plus j L2 omega minus 1 by c omega. Okay. And after that you want to multiply these two. Okay, so obviously it is minus minus becomes plus. Already you are having one minus j squared m squared omega squared, right? So obviously this j squared, minus 1, so it becomes, right away can I write plus here plus m squared omega squared, right? Or otherwise let me write one more equation. This is minus minus, so minus becomes plus j m omega v1 divided by Rs times R2 plus j L2 omega minus 1 by c omega plus m squared omega squared. This is my I2. Take equation number 2, right? Already we are having equation number 1. Okay, 1 to 3 வச்சுக்கலாம். Or otherwise take, where is my v2? v2 இங்க இருக்கு இல்லையா? This is my equation, right? v2 I2 times, take equation number some a. Okay, so I2 times 1 divided by, this is equation number, take 3. Now substitute equation number 3 in a. Okay, we know v2 equal to I2 times 1 divided by jc omega, and replace the I2 equation, I2 expression, jm omega v1 divided by Rs times R2 plus j L2 omega minus 1 by c omega plus m squared omega squared. This is my I2 times 1 divided by jc omega. Now what will happen? J cancel, omega cancel. So remaining I am having, m times v1, okay, divided by Rs times R2 plus j L2 omega minus 1 by c omega plus m squared omega squared. Here I am having this c, right? So multiply this whole things by c. Okay. So this is my V2. I'm looking for, voltage gain. That is that is my required voltage gain V2 by V1. So obviously it becomes m divided by c times Rs into R2 plus j L2 omega minus 1 by c omega plus m squared omega square. Okay. So this is my required voltage gain. It's very important. Okay. So two things. Okay. Final problem solve பண்ண போறோம் by using this formulas. That is important. Okay. So first one you want to know what is your I2. Equation number 3 is important. Okay. There may be a chance for asking the current which is flowing through tuned circuit, right? Nothing but coil 2, loop 2, that is I2, and maximum voltage gain. Okay. AV. Voltage gain is given by AV. So sometimes there may be chance for asking output voltage, right? So output voltage is given by this formula, V2. This is my output voltage, okay? And divide the output voltage by input voltage, it will give you gain, that everyone knows, okay? So that's the thing, but two more interesting observation. Number one, at resonance, what will happen? At resonance, what do you mean by resonance? Now take this tank circuit, okay? Take this tank circuit, okay? When resonance will occur? When resonance will occur? Anyone please? The reactance offered by the inductor equals reactance offered by the capacitor, right? Xc. So what is XL2? This J L2 omega equals 1 by J C omega. Okay. So what is this? J L2 omega minus 1 by J C omega equals 0, right? Or otherwise take J as common. Okay. So it becomes L2 omega. Okay. So take the magnitude. So when resonance occur, okay, by using this I am deriving this relation. Okay, now substitute this relation here. Okay, so when resonance occur, if these two are equal, right here, if these two are equal, at the time resonance occur. So let me give the conclusion. At resonance, okay, L2 omega, right, the reactance offered by the inductor equals the reactance offered by the capacitor 1 by C omega, or otherwise L2 omega minus 1 by C omega equals 0. Okay. So substitute L2 omega minus 1 by C omega equals 0. Then you will get, okay, the output voltage, okay, at resonance. Okay. It's very important. Find output voltage at resonance. அப்படின்னு question கேட்கலாம். So V2 at resonance. What is the formula? Now it will be simplified. Substitute. Okay. So this is my take equation number some B, right? So here now substitute this equals 0 because at resonance both the letters will be cancelled. So there is no imaginary part. So what you will get? This is m times V1, m times V1, okay, divided by C times Rs, okay, into R2 plus m squared omega squared. This formula is very important. What is the output voltage at resonance? Now gain at resonance, okay, gain at resonance. So gain that you know, right, V2 divided by V1. So now bring this V1 to the left hand side, that will give you gain. So gain at resonance m divided by C into Rs plus R2 plus m squared omega squared. And one more thing, what is I2? Okay, at resonance. That you know the formula for I2. I2, here it is the formula. So now at resonance, this becomes 0. So what else remaining? Jm omega V1. Okay, let me do one thing. Let me copy this better. Okay, so this is my, paste it here. Okay, so this is my, I2, but here you want to make this one as 0. Okay, if you will make this one as 0, then what will happen? Okay. So RS R2 plus what is there? M times squared omega squared. Okay, so this is I at resonance. Okay.
சார்
Hmm.
ஒரு நிமிஷம் மேல அந்த ரெசனன்ஸ் கண்டிஷன் போகும்.
Hmm. At resonance, ரொம்ப simple. At resonance, okay, the reactance offered by inductor and offered by capacitor both will be cancelled. அப்படி இல்லைன்னா both are equal, right? இப்போ இந்த ரெண்டு ஈக்குவல்னா இது மைனஸ்ல இருக்கு, அப்ப என்ன ஆகும்?
இல்ல அது ஓகே சார். அந்த மேல அந்த டேங்க் சர்க்யூட் கீழ ஒன்று இருந்தீங்க, அது கிட்ட வாங்க சார்.
இதை விட்டுரு. You want to consider this, sir. Don't consider this. You want to take the magnitude.
ஓகே சார்.
Okay, don't take J.
ஏன்னா J அப்புறம் அங்க L2 ஒமேகா is equal to minus of 1 by C ஒமேகான்னு வருமேன்னு பார்த்தோம். J இன்க்ளூட் பண்ணீங்கன்னா J ஸ்கொயர் ஒரு பக்கம் வந்து
take the magnitude.
ஓகே சார். ஓகே.
Okay, because resonance எப்ப occur ஆகும்? Magnitude of both will be same, right? So you want to take the magnitude. அதுதான் இங்க எக்ஸ்பிளைன் பண்ணேன். ஓகே, J டைம் தனியா எடுத்துறேன். புரிஞ்சா? So you want to know these things. What is the output voltage, what is the gain, and what is the output current, okay, at resonance. These three formulas are important. Okay, in general, what is the output voltage, what is the maximum, what is the gain, and what is the output current, that you want to know. 6 formulas, right? And the final one, maximum voltage. When maximum voltage will get? Any idea? With respect to what is this? Right, it is, yeah. So D, output voltage, right? I want to get maximum output voltage, okay, to find output voltage V2 maximum. So maximum means, at maxima, difference, slope becomes 0. So with respect to actually mutual inductance, it becomes 0. So D by dm of, what is your V out? Nothing but V2. V2 is given by, at resonance, V2 is given by M divided by P times Rs R2 plus omega R. At resonance, right? So at resonance, this omega becomes omega R. Please make a note. At resonance, right, the omega becomes omega R. Because all are resonance, so omega becomes omega R. Omega becomes omega R. So this is omega R. What is the formula? Omega R squared M squared. Okay. So you want to differentiate, okay, the maximum voltage at resonance, the voltage at resonance to get maximum voltage. I repeat, to calculate maximum voltage, we want to differentiate, okay, the voltage with respect to mutual inductance, and you want to equate that one to 0, because at maximum there is no slope, right? Slope 0. If you will differentiate this, it is very easy to remember the final expression. Okay, what is here? Here the first term, it is Rs R2, second term omega R squared M squared, both will be equal. If you will differentiate this, you will get Rs R2 equals the second term omega R squared M squared. Okay, from that, what is the condition for max? What is the M value? So M, it is Rs R2 divided by omega R squared equal to M squared. I'm looking for M, so M equals square root of Rs R2 divided by omega R. It's very simple. Okay, if you know this equation, voltage gain at resonance, then the condition for maximum voltage gain, nothing but M. It is very easy to end up with this formula once if you know this logic. Okay, so shall we derive this? So what will happen? That you know the story, right? Just you do the derivation by yourself. I don't want to take much time. Derivation part you please complete. Okay, in case of any doubt, please refer my material. I will forward it. So here the condition is, it's very simple. Omega r squared m squared. Please verify by yourself, right? Equal to rs r2, or otherwise the condition m equals square root of rs r2 divided by omega r. Okay, so this is the condition. So now at this condition, what is the value for this v2? V2, m divided by, this is c times rs r2, okay, plus omega r squared m squared. Now substitute this m value here. Okay, so from this, what is the maximum voltage gain? V2, I mean, this is actually VAV, right? Voltage gain, right? AV formula, right? This formula I took. Or otherwise, just take V2, output voltage formula. Then we will come to gain. Okay, so take this formula, V2 m times V1. So take this formula, M2, sorry, V2 output voltage M times V1, okay, divided by C times square RS R2. 2 plus omega r squared m squared. To calculate maximum output voltage, which is given by m square root of rs r2. Okay. Guys, are you there? So it becomes square root of rs r2. Okay. நான் தான் நடத்திட்டு இருக்கேன்னு நினைக்கிறேன். Square root of rs r2 times v1, okay, divided by omega r, okay, into c 2 times rs r2. If you will simplify this, then you will get v1 divided by 2 times omega rc square root of rs r2. This is my maximum voltage gain. Okay, similarly you want to find maximum, this is maximum output voltage, and maximum voltage gain AV max, okay, that is given by V2 max divided by V1, so it will give you 1 divided by 2 omega RC square root of RS R2. Okay, similarly find I2 max. What is the value for I2? This is my I2 resonance. Okay, take this formula. So here also please substitute. Okay, this m squared omega r squared. Okay, replace this m squared omega r squared by rs r2 and replace this m by square root of rs r2 divided by omega r, and you can find the I2 maximum value. Okay, so similarly find I2 maximum equals, so what's the value? J omega v1 square root of rs r2 divided by omega r, this is also omega r, divided by, what is that, rs r2 plus rs r2, right? So rs r2 plus omega r squared m squared replaced by rs r2. Okay, so these two will be cancelled. So remaining you end up with j v1 divided by 2 times square root of rs r2. This is my I2 max. Okay, okay, have I sent material for coupled coils? Yes or no, at least? or otherwise I will send the material. Okay, in that I have given one problem. Okay, you want to find the resonance frequency, find the resonance. They will give the circuit and you want to find the resonance frequency and you want to find V out, output voltage, and you want to output voltage at resonance, and you want to calculate output voltage, I mean maximum output voltage, so V out max. Okay, I have given all the formulas. Okay, so this is about tuned circuit. Today sound is not good, so I want to complete the class. Okay, thank you, thanks for your support. ஏதாவது டவுட் இருந்துச்சுன்னா ஸ்டே பண்ண, otherwise you can leave. Let me stop the recording. Thank you. Happy Deepavali.